Welcome back to Computer Science MS5, and in today's video we're going to be looking at memory. We're going to be able to describe RAM as volatile memory used for holding data instructions in use. We're going to explain how virtual memory acts as extra main memory when RAM is full, and we're going to describe the purpose of ROM. So what do you already know about memory and its role within computer systems? Well, if we take a look at the model of a computer system, the von Neumann's architecture, computer system takes inputs, it processes them, and produces outputs. And we've got memory there, and memory is where data and instructions are held. And we've talked about memory in the von Neumann's architecture, we've talked about memory in the fetch, decode, execute cycle, and now we're going to take a deeper look at what memory is, mainly looking at primary memory or main memory. So there are two types of primary memory. We've got RAM, which stands for random access memory, and we've got ROM, which is read-only memory. And a nice way that you can remember that is PRAM and PROM. The P is for primary and PRAM and PROM. So primary memory, RAM and ROM, read access memory, random access memory, and read-only memory. So let's take a deeper look at RAM. Well, random access memory is used as main memory, and that over there is what a stick of RAM actually looks like. If you open up your desktop computer, you'd probably find a stick of RAM just like that. It's a component of the computer, it's physical, you can touch and hold it. And it can be read from and written to. So what does that mean? Well, in the same way that guy is reading from a book and writing to a piece of paper. When you're reading and writing data, you're reading instructions and you're writing data back into RAM. So it can be read from and written to. And access to RAM is very fast. Now, we need to always compare when we're talking about speed. So it's faster than accessing secondary storage, and it's very fast for the CPU because the CPU fetches instructions and data from RAM during the fetch, decode, execute cycle. RAM holds data and applications that are open and in use. So anytime I open up a program, it's going to be held in RAM. And an example of those programs could be the operating system, like Android or iOS or Windows, and software that's currently in use. So right now, this presentation software I'm using is being held in RAM, and any documents or files. So there you go, that's RAM holding lots of different things that are in use. And finally, when your computer is off, RAM is empty, as RAM is volatile. So when you switch off the power, RAM is empty. So remember that key word volatile, really, really important. RAM is volatile, it means it's temporary. So RAM is volatile. All the data is lost when the power is off. So if we take a look at RAM right now, it's empty. RAM holds data and applications that are in use, and when your computer is off, RAM is empty as it's volatile. Volatile memory is temporary and requires power to hold its contents. And that's why when your computer suddenly switches off while you're in the middle of doing some homework and you haven't clicked saved, you lose it because it hasn't been saved to secondary storage, which is non-volatile, which is permanent. It's just in RAM because you're currently using it, so you lose everything. So right now, imagine my computer's off because I've got all those little locations in RAM and they're all empty. So what's the first thing that's loaded into your computer? Well, when you power on your computer, the startup instructions load the operating system into RAM. So if we take an example, Windows as an operating system, don't use Windows as an example in your exam, or you can use it as an example, but you want to say the operating system. You won't get any marks for just saying Windows is loaded into RAM. So the first thing is the operating system, because that's always in use, so it's always going to be in RAM the moment I power on. Now, when applications or programs are loaded, i.e. I click on them, they're copied into RAM from the hard disk, which we're going to look at in a second. So documents or data that are used with those programs are also opened by copying them into RAM. So as I open up Microsoft Word or Snapchat or Apex Legend, I'm slowly loading them into RAM, and that's because they're open and in use, so they're held in RAM. Now, as you can see, RAM starts to fill up. The space is limited. So let's say I suddenly want to listen to some music and I need to open up SoundCloud. Well, my music application needs to be loaded into RAM, but there's no space. So what's going to happen? RAM has a limited amount of space. Any documents that are open and in use are loaded into RAM. But at what point have you been using a computer when suddenly it says, I can't open this, RAM is full? Definitely starts to slow down. Well, we've looked at RAM, and now we're going to look at something called virtual memory. And virtual memory is secondary storage temporarily used as RAM when RAM is full, or temporarily used as the main memory when RAM is full. So here's just a quick look at what secondary storage is, and we're specifically talking about hard disk drives. So a hard disk drive is secondary storage. It is non-volatile, so it's permanent, and used to store data and applications when the power is off. Now, we're not particularly talking what secondary storage is. We're talking about virtual memory, which uses secondary storage. So here's a picture of my hard disk drive. There's RAM, which is full right now. And the first thing that we're going to do is virtual memory is a segment. So it's not actually the hard disk drive, it's just a segment. It's a segment of the hard disk drive, a little part of the hard disk drive. And it's used as an extension of RAM when RAM is full. So I'm going to just pop SoundCloud in there because it's open, but I'm still not actually using SoundCloud. It's open, and I'm using a segment of the hard disk drive as memory because RAM is full. So how does that work? Well, data and applications open but not in use are moved to virtual memory, so they're moved to that section of the hard disk drive. And this means that I can actually have more applications open at the same time. But what happens when I actually want to use that application? Well, data and applications need to be switched between virtual memory and RAM when the CPU needs to access it. And the reason being is because the CPU can't actually fetch data and instructions from secondary storage. It still needs to fetch those data and instructions from RAM. So whenever I want to use it, I need to switch it out. So now I need to listen to some music. What's actually going to happen is I'm going to stop playing Apex Legends and I'm going to listen to music. Or maybe it will switch with Snapchat if I'm not losing that, or it will switch with Microsoft Word. And this makes it a little bit easier because I can have lots of data and instructions open at the same time, but there are some disadvantages. So if we look at the pros and cons of virtual memory, well, the advantages are more data and applications can be open at once. So I can go back there, I can multitask, and I can have like all my different programs and apps open at the same time. And I'm just using that segment of the hard disk drive to help RAM temporarily. Well, the disadvantage is switching between RAM and virtual memory is slower than directly from RAM. And that's because every time I want to use an application that's open, it needs to switch out of RAM and back into secondary storage, and then whatever's in secondary storage needs to switch around. So these are the pros and cons of virtual memory. So we've looked at RAM, we've looked at virtual memory. Now we're going to look at read-only memory, so ROM. I'm just going to start with a question and a bit of a thought that some data needs to be permanently held in memory, even when the computer has no power. Now, we can't use RAM because, remember, RAM is volatile. So where can we permanently hold data in memory even when the computer has no power? And another question to think about is, what instructions do you think a computer must instantly execute when you first switch on a computer? So if RAM's empty and data and instructions are fetched from RAM, and I switch on my computer, well, there's not going to be anything in there to fetch. So here's a little hint. The first instructions that you actually fetch are the instructions to boot up your computer. That doesn't literally mean kicking your computer. It means to start your computer. So read-only memory, ROM, contains the BIOS. And the BIOS is the basic input-output system. And this tells the CPU how to boot up, or it tells the CPU how to start the computer. So the moment I press the power button, there's a piece of non-volatile memory called ROM, and that holds instructions for how to start the computer. And the CPU gets those instructions, and then it knows how to boot up the computer. And it also performs diagnostic checks just to make sure that the computer system works. Kind of like when you wake up in the morning and you need to figure out, well, where are my arms? Where are my eyes? Okay, I can see things, I can hear things, I know where I am. And then you can start actually doing things like getting dressed and brushing your teeth. And that's what ROM does. It holds those really simple instructions that tells the computer, these are your basic inputs and outputs, and these are all the checks to make sure that you're running correctly. Now, ROM, it's in the name, it's read-only memory. So that means you can only read it and you can't edit it. And that's really important because Potentially, someone could edit those instructions for starting your computer, and that could give you a few problems. So it's really important to know that ROM is read-only memory. You can only read from it. You can't change or you can't write to it. And finally, it is non-volatile. And that's, again, really important, because if ROM was volatile, every time I switched off my computer, I'd lose all those instructions for how to switch it back on again. So it's read-only, so I can't edit those instructions. And it's non-volatile, so it retains its contents when the power is off. And that's also why I can't use secondary storage, because secondary storage can be written to, and that's why I can't use RAM, because RAM is volatile. So thanks for listening to this video. Go back and watch over it again, take some notes, ask yourself those questions, and you should be able to describe RAM as volatile memory used as holding data and instructions in use, explain how virtual memory acts as extra memory when RAM is full, and finally describe the purpose of ROM for booting the computer system. Thanks a lot for listening.